And welcome to the Daily Space Weather Show. Mixing things up a little bit tonight. And shortening the video. Yes. Yes. Because you have to have priorities between Chinese food and space weather. So, imminent eruption likely at Grindavik. That's the first thing. Also, U.S. earthquake risk. These are the erupting volcanoes. Pause it if you like. Read them and weep. Those are the places that are erupting at the moment. And moving on promptly to earthquake activity. So yeah, like I said, U.S. earthquake risk. First of all, we're having an earthquake drought. If you're in a tsunami-prone region, be aware of that. Earthquake droughts. What do they end in, viewers? What do they end in? Please let us know in the comments what you think earthquake droughts end in. You know, large earthquake droughts. Any ideas? Anybody? Anybody? So the swarm continues at Alaska for the past 24 hours. Check it out. More quakes there around Anchorage. And more quakes on the western plate boundary for North America and South America. So that's a thing. These are the quakes that have been going off. And I ain't calling out Jack. You can check out the USGS site yourself. There was one in the Aleutians there at a 5.5 magnitude. So, of course, the Pacific Rim, also quite a few quakes on the western portion of the Pacific plate. Back to space weather, the radio flux is now at 180. 180, I think, solar flux units. 183? 180, I think. Yeah, 180. There you go. Space Weather Enthusiast Dashboard can confirm this. And what are they forecasting? Not a lot of anything, and we haven't had a lot of anything. So, next Earth magnetic moment from space for the past 4 hours. And again, it's geomagnetically calm, so not a lot to report on. We'll show it anyway for your model viewing pleasure. It is a 4-hour model of magnetohydrodynamic pressure. The space weather modeling framework uses many variables to create it. Also, the ground magnetic perturbations map. This one might be useful for you to see aurora when there are times of geomagnetic storm conditions. It's showing you the most likely places for induced telluric currents, for aurora overhead, and so forth. The ground magnetic perturbations map shows magnetic flux density. Next is our KP index, which is at 1.33. 1.33 for the KP index. Again, it's geomagnetically calm. Spacecraft showing weak solar wind, both slow and low, only 430 kilometers a second, only about 2.5 protons per cubic centimeter, so just a little above normal, above average there, 430 kilometers per second. Nothing to write home about. 450 kilometers a second at Discover, 6 proton per cubic centimeter, 5.3 proton per cubic centimeter. Density, GOES magnetometers here are going to be smooth. It's clear sailing, space weather at the moment. And Earth is in a North Pole-oriented magnetic sector, but it's going to be short-lived. So within 3 days, Earth likely to be in a South Pole magnetic sector once again, as shown in our top view ecliptic plane field plot, part of the Gong 2 data, the National Solar Observatory, rather. And here's our line of sight field plot depicting some great information there, all in one. The solar photosphere, the B field, the polar fields, all in one very convenient 4-day animation. Time and date stamps are included there below the imagery. Here's our line of sight coronal hole plot. And we've got both polarity coronal holes. Let's take a look at those from the perspective of SDO. So there you go. There's SDO 211 angstroms. That is just for today, February 28th. The day before Leap Day, the end of the month. It's a weird holiday. People are going to be jumping rope and doing the Fosbury flop because it's leap day. Of course, right? Gotta have it. So, yeah, all right. So what's next? Sunspots are next, right? Sunspots? I think that's a thing. Coronal hole's not too exciting right now. Sunspots, space weather's kind of boring at the moment, frankly. Of course, we've always got the bonkers imagery for you, but there is the sunspot number still here right around average here, according to Rob of the Royal Observatory of Belgium. Only at about 120 sunspots, 118, something like that, 118 sunspots. And I've got a thing there that I don't want there at all, so let me bring up the actual thing that I want, which is supposed to not be that. It's supposed to be this. So, and by the way, folks, this video is not live, but it does appear to be live because, oh geez, things are just working weird. It's almost like a live stream because we don't edit the videos. That's how it gets onto your screen so promptly. But anyway, so there's our flare probability monitor, and of course sunspot 3590 is still very likely to produce large flares. Let's take a look at it. Of course, in your upper screen right there above your Earth scale, the northwestern limb. And as it approaches that northwestern limb, it certainly is becoming more likely to produce X-class solar flares. It produced a long-duration M-class flare just earlier today. And yeah, the likelihood of X-class flares rising, assuming that thing stays in its stable state that it currently is in, believe it or not. It doesn't have to get more complex to produce an X-class flare. It's certainly capable with the fields it has and with the angle that is approaching as it gets nearer to the limb. If you have theories, by the way, as to how and why it is that we see more large flares closer to the limb, there's probably some physics explanation. If you want to throw your 2 cents in, definitely let us know in the comments what you think as to why limb flares are slightly more likely to produce higher magnitude events. So here's the ultra close-up of sunspot 3590. And we've adjusted the viewing here so that the field of view rotates, which makes it sort of stationary, but it gives you a good perspective as to how massive that group of sunspots is. Tens of thousands of kilometers there. Something like, I don't know, 50,000 kilometers there in between those groups. Just the leading set, I mean. And here's our magnetogram also. So pretty stable there and pretty high degree of magnetic shear. Likelihood of X-class solar flares extremely high. I'd say over 50%. Before we get to that, let's look at the stats. No spikes in the proton flux, no relativistic particles showing up despite this long duration M-class flare that we just had. Peak flux was around M1.5, so a fairly modest M-class flare, but of long duration. It definitely did accompany a coronal mass ejection. You'll see that from sunspot 3590. No surprises there. Will it be earthly directed? It may be too early to tell, but we'll see what we can do. Probably be able to tell. There's 94 angstroms. The equatorial view of some ionized iron gas, ultra hot ionized iron gas emitting extreme ultraviolet radiation. So here are some more close-ups of sunspot 3590. We definitely didn't skimp on the awesome imagery tonight, as you may have come to expect from the channel. This one happens to be 131 angstroms plus 171 60-minute running difference. Really shows filamentary features well. highlights them in such a way that you can almost see their source locations and so forth. That is 30 frames per second, a 24-hour video from the Solar Dynamics Observatory. Sunspot 3590, just epic. The largest flare-producing sunspot so far of Solar Cycle 25. So let's move on here. Again, there are things calling me, and I'm listening because they're delicious. That's why. So let's move on to a star chart. There you go. That's what's going on overhead with us. We've got Jupiter up there right now, as well as Sirius, so the largest planet and the brightest star. Next, our forecast. We show a forecast for the solar system, folks. Is that blasphemy? Oh my God. Dear God. So here is our solar system forecast. This is 1 week. That's where things will be in a week. We'll have a crescent waning moon on this lonely side of the solar system, folks, with no other planets. Next, our astronomy photo of the day. That's yesterday. There's today, and it's shades of night. Ah, yes. Different funky colors that show up around a sunset. Always very nice. Belt of Venus. All right. I honestly don't have time for this because it's apod.nasa.gov if you want to read about the different refraction causing different spectra to appear in your nighttime sky. I'm over that. That's not really space weather for the most part. That's the neutral atmosphere entirely, in fact. So, moving right along to CMEs. So, let's see what we have for today, since that's yesterday. And we have a pretty significant event there in the northeast. And then something out of the south. We don't see one out of the northwest. And we've got old data. So let's see what we've got from... I think we've got the new stuff from these. So let's check them out. You're finding out at the same time I am, perhaps. And we're cutting to our custom coronagraphs because that was weak sauce. We got to use our custom coronagraphs, folks, because that's not weak sauce. So there we've synced the SDO 304 angstroms with the coronagraphs from SOHO, and that is just good stuff. You've also got Mercury there on the C3. And what do you got? You got Earth-directed CMEs? Maybe. Could be. There could be Earth-directed components in multiple events here. We see an event out of this sunspot. What's up with that? Oh. So that one probably has an earthly directed component. Check it out. Right in here. Oh, the imagery is so weird. I don't know. You be the judge. I'm undecided about that. Let us know in the comments what you think. Perhaps the event came from out of here? I don't know. But if anything came out from this close to the center of the solar disk, it's likely to have an earthly directed component. So I don't know. I'll give it a 60-40% chance of impact. So you're looking 3 days out, so that's sometime late in the day on the 2nd would be impact time, assuming it's not at some weird speed. But it's very hard to tell speed with an object that's coming directly toward you. So anyway, here's some additional imagery here of sunspot 3590. And that is it. That's the end. That's the complete end. And so, yeah, so if you'd like more space weather, too bad. We're cutting it right there. And as far as meteorology, we're not covering it. So I know we normally cover a meteorology segment, so by all means, if you're mad that we didn't, let us know in the comments. Maybe I can show. Can I show a couple things? I can show a couple things, right? There's enough time. So here, I'll show some meteorology. Sure. There you go. There are the jet streams. Planet Earth. These are the jet streams of your lives. Like sands through the hourglass of time. These are the jet streams of your lives. Hopefully you're not hopefully your soul is not locked in a dead dog's soul's attic of his dead doghouse in dog heaven. Imagine that. Imagine if your soul was encased in a demonic amulet in some dog's attic in dog heaven. That would be fun, right? You'd be like a genie in a lamp, and a dog's soul has to rub you. That would suck. All right, so moving right along. No more soul statements. However, if you don't press like, your soul may be cast into an ever-deepening and darkening abyss of doom, destruction, and CNN news commentary. Whoa! Stick with SNN, least busted name in news. It's a little bit more credible, perhaps. Facts. Facts. They're super dangerous. Ooh. And there's precipitation on its way out of the east. It's going to blast its way out as there's some cold air blasting through. Blasting through. We got blizzard watches in certain places, and we've got a bunch of stuff that we can't access. So we'll show you the U.S. Doppler radar, and then we'll call it a day. So there you go. There's the lower 48, and we are out. So talk to you soon. And in the meantime, may that solar wind be at your back.